In the last session, we discussed about health pickup, uh, prefabs. So the last topic was health pickup creation. Yeah, we discussed about prefabs, building and managing a basic level and hierarchy organization, about game design, custom materials. So today we're gonna discuss about lighting. So in Unity, lighting plays a crucial role in setting the atmosphere and realism of your game environments. It can be the difference between a flat, dull scene and an immersive, dynamic world. Unity simplifies the control of lighting by categorizing it into real time and pre-computed. So let's discuss these on how they brighten up your game. So real time lighting, this is calculated live as your game runs. It means that no matter where and how your game object moves, they'll cast and receive shadows dynamically as you'd expect in the real world. So this, however, demands more from your hardware, might impact performance in graphics heavy games. We have pre-computed, which is a baked lighting. So here the games lighting is calculated in advance and baked into the environment. Objects that utilize baked lighting don't impact the rendering engine per frame, so they are kinder on your computer's capabilities. The catch here is the baked lighting and uh, the shadows they produce remain where they were made, static and unchanging. So no matter how the in-game objects move. And we also have a mixed reality with computed real-time global illumination, which this is Unity's throwing you a halfway uh, between real time and pre-computed. So it aims to provide a near realistic effect of global illumination and dynamic reflection without as much computing uh, required. So however, it's a dive too far down the light light well for us in this text. So just as the directional light in Unity's project's opening scene, you can punctuate your scenes with baked candles or live wire lasers by wiring them up in the hierarchy alongside all your ground planes and sprite characters. So there are different types of real-time lights. We have directional light, point light and spotlight. Directional light, picture this as your own path of the sun, setting a primary influence over the environment in a one consistent spill and an overall minion of the modes you want to evoke. And we have point lights. These are your bulbs in the night. uh, yeah, they basically act as a bulb. Spotlights, it's the it will be like a watchtower in need when wherever beamed boundaries and sectors of area needs focusing. uh, yeah, spotlights can be a very useful uh, tool in that situations. So for touches of terrain in general, for touches of terrain trade secrets, you command the colors and the cast and the council of mode by the hue of light, the cache of light data to go the way of character movement. And so next topic is animation. So animating objects in Unity transforms static scenes into dynamic experiences. So here in Unity you have a animation window. um, so you basically create and edit animation clips through a timeline and record property changes over time to animate your objects. And whereas animator window, uh, which manages animation clips and the transitions through the animation controllers. So how to create animations? uh, we need to have a animator component which is necessary for any game object you wish to animate, so which is automatically attached when creating a new animation clip. uh, Animation controller basically orchestrates the playing of the animation clips. Unity creates one if absent during the clip creation. I've already created an animation, so that's why we have an animator clip controller here. So creating an animation clip for our pickup item, the health pickup item. So when you go to Windows, you'll find animation and again animation. So this is your animation panel. This is where you'll craft your animations clips. So with your game object selected, which is health pickup, you create a new animation clip, uh, and so yeah, I've already have a clip already. You could create a new one and save it. You could create a folder named animations, and you can save all your animations in that folder. So upon creating a new clip, Unity adds a animate component to your game object and generates animation controller linking your clip to the object. And animation clips in Unity are made of keyframes, capturing the game's object state at specific times. And we also have a looping animation, which is perfect for effects like spinning a health pickup item. Simply adjust the object rotation over time in the animation window, setting start and end keyframes to create continuous spin. We'll discuss about that later. But yeah, you basically first you select your health pickup prefab in the hierarchy, and open the animation window and click on the create to start a new animation clip. And Unity asks where to save the new clip, organized by creating an animations folder. And with the clip active, use the record button here. This is your record button in the animation window to capture the rotation changes over time for a loop spin effect. So by following these steps, you'll animate the health pickup prefab for to continuously spin, adding visual interest and dynamic behavior to the object without writing a line of code. Unity's animation tools are powerful and flexible, enabling complex animations for character movement, UI effects, and environmental animations to enhance your game's immersive quality. So next, yeah, so we'll discuss more about the spinning animation with keyframes in Unity. So recording keyframes in Unity allows you to animate game objects by capturing the changes to their properties over time. So let's understand the keyframe recording in Unity for spinning animations. So let's go back. So the capture keyframes are the cornerstone here. They capture and hold the state of the object's property like rotation at a specific point in time. Unity uses these snapshots to interpolate motion between keyframes, creating a smooth transition. So with the animation window open, you'll see a timeline. Uh, so this is where you'll plot the keyframes for your animation. So when you click on the record button, red circle, which is the record button in the animation window, this puts Unity in a record mode, ready to capture any changes to the objects properties. And uh, and you can change the rotation. You can adjust the game objects properties. For a spin animation, you'll alter the z-axis rotation at several points. Like at 0, it's 0 right now. At 30, I've changed the x-axis, but yeah, you could you could experiment with it. Yeah, so I've already put an animation, so that's why we have a number here. So yeah, for a sprint animation, you basically for at zero, time zero, you'll have 0 degrees for z-axis, and at time 30, the 30 seconds mid, which is a midpoint, set to at 180 degrees for the z-axis, and at 1, basically it's 60. So at 60 seconds, you'll you'll put it as 360 degrees, and when you click on the stop record, uh, you click on the record button again to stop the recording changes. Unity has now created a will now create an animation clip based on the keyframes you have set. Let's see. Yeah, I've experimented with it. I've just put a random number for y-axis also, so that's a bit changing. Yeah, yeah, this is how it works. Let me change some values. Saved. Let me try again. See if that's saved. Yeah, yeah, you can yeah. Yeah, experiment with it and see how it's working. Timeline and the keyframe setting dictate the object will rotate 360 degrees every second until Unity automatically loops this animation, creating a continuous spinning effect. And you can use the play button as I used in the animation window to preview your animation. This ensures your game object spins as intended, and once satisfied, you can uh, this animation clip is attached to the object game objects animator component playing back in the game scene. So this process explains the fundamental steps in animate to animate objects in Unity, showcasing keyframe recording role in bringing static objects to life. So by adjusting keyframes, you can create complex animations that enhance the visual appeal and interactivity of your game. So next topic is yeah, smoothing animations in Unity with curves and tangents. So in this segment, we'll discuss how Unity allows for notched control of animations through use of curves and tangents, which are important for creating smooth transitions and realistic movements in your game objects. First, animation curves. So Unity's animation curves provides a visual representation of how an animation property changes over time. By adjusting these curves in the curves view of the animation window, you can fine tune the speed and the timing of your animations, creating more dynamic and natural movements. We have curves view. Switching to curves view reveals a graph that displays the progression of animated properties over time. Keyframes appear as points on the graph, and the curves shaped between these points dictate the animation pacing and transition. We have linear non-linear animations. Our goal with the health pickup object was to achieve a linear smooth rotation. By default, Unity interpolates between keyframes linearly unless modified, which suits our needs for continuous spinning effect without sudden changes to the in speed. And adjusting tangents to refine how animations transitions from one keyframe to another. Unity offers tangent options. Adjusting tangents can smooth out or sharpen the entry and exit of the keyframes, eliminating any jarring pauses or unnatural movement speed. For our spinning animation, setting the tangents for the first and the last keyframes to auto uh, ensures a seamless loop by continuously interpolating the rotation values. So yeah, to apply this, you click on the diamond icon representing the first and last keyframes in the dope sheet mode and select auto. This minor adjustment makes a significant impact, smoothing out the animation loop to eliminate the noticeable stutter at the start and end points. So beyond basic animations, while the focus here is using Unity's animation window for direct manipulation of objects' properties. It's worth noting that Unity also supports scripted animations. This this method involves changing the object properties such as position, rotation, scale through C# scripts, uh, offering another layer of control for complex and or procedural generated animation. So animation in Unity is a deep and broad topic with advanced features like programmed animations and sophisticated effects using the Unity's particle system. While this overview touches the basics necessary for projects, there are many possibilities of for those interested in going deeper into Unity's animation capabilities. So yeah, this introduction to curves and tangents in Unity's animation highlights the importance of these tools in creating smooth and engaging animations. So by understanding and utilizing these features, you can enhance the visual appeal and fidelity of your games animations, uh, which contributes to more dynamic player experience. Next topic is particle system. So when discussing about Unity's particle system, it's essential to understand it as a powerful tool for creating dynamic visual effects, ranging from simple sparks to complex environmental phenomena. So yeah, Unity's particle system is a component that simulates fluid effects such as liquids, clouds, flames by emitting and managing thousands of particles. It's a key feature for adding visual flair and feedback in games, enhancing the player's immersion. So to start with particle system, so to start with the particle system, you can add a particle system to in your scene by going into create menu, uh, effects, and you'll find particle system. So I've already have a particle system for our health pickup, but I've created a new one. Uh, so so This system emits particles, which are small sprites or meshes, to simulate various natural and artificial effects. So once added, you can customize the particle system behavior and appearance extensively. So the key properties in your it will be you'll find the properties in the inspector panel when you select your particle system. First, we have a start lifetime, which determines how long each particle remains visible before disappearing, and we have a start speed, which controls the initial speed at which particles move, and we have a start size, which adjusts the you can adjust the initial size of the particles, and we have start color. uh, you can set the initial color of the particles. Yeah, you can change and you can. So and we have a emission rate. Is emission rate. Yeah. So emission section allows you to specify the rate at which particles are emitted, ensuring a consistent flow or burst of particles as needed. And we have shape, which is particle shape. Uh, So the shape section defines the geometric starting point of particles such as sphere, which can help in aligning the particle effect with the object it's meant to enhance. So to make collectible items in your game more noticeable and appealing, you attach the particle system to create a sparkle or a glow effect around them. So this not only draws the player's attention, but also adds a game's aesthetic uh, quality. Yeah, so yeah, create a particle system object and position it appropriately, and adjust the particle system's properties for desired visual effects like setting a gentle speed, modest size, attractive color, and use the emission settings to control the density of the particles and the shape setting to match the effect to the object's form. So that's about particle system. So in this topic, we for Unity, we discussed about Unity's toolset for bringing uh, game worlds to life. So this topic was designed to bridge the gap between pure C# programming and the multifaceted uh, world of game creation, providing a fundamental understanding of essential game development uh, topics. So we discussed about we started with a primer on the game design, underscoring the importance of a well thought out blueprint of game development, the concept of a game, its core mechanics, control schemes, narrative, visual style, victory or defeat conditions were highlighted as important elements in crafting engaging games. And then we discussed about level creation, so which yeah, transferring we basically transitioned from theory to practice. We explored the process of building the game levels. We utilized Unity's tools. We learned to shape the environment that not only appeal visually but also complements the game mechanics and storytelling. So this yeah, the session uh, covered creating primitive game objects and arranging them into a coherent level layout, emphasizing players' perspective and interaction with the game world. And we also discussed about 3D space, which is a crucial concept of game development in Unity, which is basically navigating and manipulating objects in 3D space. The topic also provided insights into how objects positions, rotations, scales, which define their presence and behavior in the game environment. Uh, and we discussed about materials and animations. So to enhance the visual appeal of our game, we discussed uh, the use of materials for object rendering, and also explored the basic animation techniques. Those topics demonstrated how to bring life into static scenes and objects, making the game more dynamic and engaging. We also discussed about lighting and particle effects. Though briefly touched, the topic introduced the concepts of lighting and particle systems in Unity, highlighting their role in creating atmospheric and immersive game environments. So these tools allow developers to simulate realistic lighting conditions and visual effects, adding depth and richness to the game world. So this topic serves as a comprehensive introduction to the non-coding aspects of the game development in Unity, helping you with the knowledge to start shaping your game worlds visually and interactively. As we move forward, we'll refocus on programming, specifically tackling the mechanics of movement, camera control, and Unity's physics system to bring life into the characters and objects within our game world. uh, yeah, thank you.